Assalamualaikum and greetings everyone. My name is Nur Shamira Farhana and today I would like to present my final year project entitled Effect of Foliar Zinc and Salicylic Acid on the Growth and Physiological Performance of Amaranthus species. This study was conducted under the supervision of Dr. Nur Aisha binti Abu Shah. Moving on to introduction. This Amaranthus viridis is an important leafy vegetable because it is rich in dietary fiber, calcium and iron, making it valuable for human nutrition. However, its growth and physiological performance can be affected by nutrient deficiencies and environmental stress. Therefore, improving plant growth through foliar nutrient application has become an important agriculture approach. In this study, 2 foliar treatments were selected, namely zinc sulfate or ZnSO4 and salicylic acid. Zinc is an essential micronutrient that plays an important role in chlorophyll synthesis, enzyme activation and plant growth. Meanwhile, salicylic acid is a plant growth regulator that improves stress tolerance and photosynthetic activity. Although previous studies has investigated zinc and salicylic acid individually, limited information is still available regarding their combined application on Amaranthus viridis. Therefore, this study was conducted to evaluate their effects on plant growth and physiological performance. The problem addressed in this study is that there are limited studies on the combined foliar application of zinc SO4 and salicylic acid in Amaranthus viridis. Previous studies mainly focus on each treatment individually, since zinc promotes plant growth and salicylic acid enhance stress tolerance and photosynthesis. Combining these 2 substances may provide greater benefits. However, their combined effects remain unclear, particularly in Amaranthus viridis. Therefore, the study aimed to investigate whether the combined application of zinc sulfate and salicylic acid could improve plant growth and physiological performance. Therefore, this study consisted of 2 objectives. The first objective was to determine the effects of foliar applied zinc sulfate, salicylic acid and their combined application on the growth or performance of Amaranthus. The second objective was to determine the synergistic effect of combined application of zinc sulfate and salicylic acid on physiological performance of Amaranthus. About this literature review, several previous studies have reported the beneficial effects of zinc and salicylic acid on plant growth. Kandaker et al. Demonstrated that zinc improved plant growth through chlorophyll synthesis and enzyme activation, while Reshma et al. Reported that salicylic acid enhanced photosynthesis and stress tolerance, while Raja Videhnavi found that salicylic acid helps maintain chlorophyll content and protects this photosynthetic system under stress condition. However, limited studies that I listed here have evaluated the combined application of zinc sulfate and salicylic acid, especially in Amaranthus species. This knowledge gap became my basis of the present study. For my methodology, Amaranthus viridis seedlings were grown using a garden soil and sand mixture with a ratio of 3:1. 3 foliar treatments were prepared, namely zinc sulfate, salicylic acid, and the combination of zinc sulfate and salicylic acids at concentrations of 0, 50, 100, 150, and 200 milligrams per liter. Twin 20 at 0.1% was added as a surfactant to all foliar spray solutions. This experiment was arranged using a randomized block design (RBD). Also, the foliar spraying was applied once every week for 4 weeks. At the end of the experiment, plant height, number of leaves, dry weight, and chlorophyll content were measured. The data that I measured were analyzed using one-way ANOVA, followed by Turkish test at a significance level of P less than 0.05. Based on the results, different treatments produced different responses. For plant height, zinc sulfate at 100 mg per liter recorded the highest mean plant height of 17.25 cm. Salicylic acid alone peaked at 150 mg per liter, while zinc sulfate plus salicylic acid combined peaked at 150 mg per liter, but all the treatments declined at 200 mg per liter. For the number of leaf, the combined zinc sulfate and salicylic acid treatment at 200 mg per liter produced the highest number of leaves, with mean of 32.50 leaves, suggesting improved in vegetative growth due to presence of significant differences across treatments, which is P equals to 0.024. Next, for the dry weight, the combined treatment at 150 mg per liter recorded the highest dry weight of 40.67 grams, indicating better biomass accumulation compared to the individual treatments. However, there are no significant detected by this treatment. Lastly, for chlorophyll content, even though it is not shown no significant differently, salicylic acid alone consistently responded with the highest mean of SPID value, which is 36.3 at 200 mg per liter. Overall, zinc sulfate promoted vegetative growth through its role in chlorophyll synthesis, enzyme activation, and plant metabolism. Salicylic acid contributed to maintaining chlorophyll content and improving physiological performance by enhancing stress tolerance. The combined zinc sulfate and salicylic acid treatment produced the highest dry weight and leaf number, suggesting a positive interaction between the two treatments under suitable concentrations. Both shown consistency with the previous studies that stated the role of zinc and salicylic acid well according to these treatments in this present study. For future studies, baseline measurements before treatment application should be included to allow better comparison of plant growth. The number of replications and treatment duration should also be increased to improve statistical reliability. In addition, future research is recommended to investigate physiological and biochemical parameters such as antioxidant enzyme activity and photosynthetic rate to better understand the mechanisms underlying the observed responses. In conclusion, both research objectives were successfully achieved. Zinc sulfate at 100 mg per liter produced the highest plant height. The combined zinc sulfate and salicylic acid treatment enhanced leaf production and biomass, with the highest number of leaves recorded at 200 mg per liter and the highest dry weight at 150 mg per liter. Although chlorophyll content was not significantly different among treatments, salicylic acid at 200 mg per liter recorded the highest numerical value. Overall, this study provides useful baseline information on the application of zinc sulfate and salicylic acid for improving the growth and physiological performance of amaranthus.